right, everybody, welcome back. We're going to look at something called the absolute value. So the absolute value is what we're looking at today. You notice I already have a number line set up with our very important key number here in the middle, 0. This is going to be our guiding point today, 0. Absolute value is a way we look at the distance of numbers from 0. The way it looks is a little something like this. I could say the absolute value, we use these two little lines here, of a number, let's say -2. What we're looking for is what is the distance of our number inside the absolute value from 0. So in this case, -2 is right here, and that is 2 away. Because it's 2 away, the absolute value of -2 is just 2. The absolute value of +2 is also 2, and we can check that here because 2 is here. We can count, it is 1. It's 2 away from 0. Because we're just looking at a distance, there's no negative value at all in our answers. It's always going to become a positive. Any positive number, or any negative number you can think of, if you give it the absolute value, will become positive. We're just looking at the distance. For example, absolute value of -10. The absolute value of -10 is just asking how far away is -10 from 0. Let's say -10 is all the way over here. Well, I could count and see, wow, that distance is 10 away. It's the same if it was on the other side. It was +10 as well. So any number you can come across, right, the answer will be a positive version of itself. Always. Forever. Always. So absolute value of -x, where x is anything, the answer is positive x. So there's your quick rundown of absolute value. So you might be wondering, what on earth is this useful for? Well, let's take a jump into some algebra and see what happens when we have an equation with an absolute value symbol inside of it. So I'm going to erase this, and I'm going to do 2 examples here, and we're going to walk through how to solve them. First example, the absolute value of 2x minus 4 equals 10. So I have the absolute value of a number is equal to 10. Okay, so my answer here is a positive number, thank goodness, because anything in an absolute value always has to be positive. So there's a couple of steps here. So the first step is we want to isolate the absolute value. We've already done that. It's by itself. We're good. The second thing we want to do is make sure we set up 2 equations. And I'll explain what I mean once I've done that. The first equation is we're going to imagine that the absolute values aren't even there and just write 2x minus 4 equals 10. And we can solve this, and we will in a second. The other equation, however, is going to be the same thing, but remember, if it's inside the absolute value, this could be a negative number. It would still equal 10, positive 10. Okay, so it could be positive, or it can be negative. 2x minus 4 equals negative 10. So we have 2 equations that we need to solve at the same time to figure out all of the values for x. So let's start with the positive side. Usually an easy place to start. And we're going to solve it like we've always been solving it. We'll put the line through, do the opposite operations. 2x minus 4, we're going to add 4 to both sides. So that makes 2x is equal to 14. Divide by 2 on both. And that leaves us with x is equal to 7. Let's see, does that make sense? 2 times 7 is 14. 14 minus 4 is 10. Perfect. Okay. So that's one solution. let's see the other solution now as well. Same idea. We're going to do our steps. So we're going to do the exact same steps, but instead of positive 10, it's a negative 10. So I'm going to add 4 to both sides, and I get 2x equal to negative 6. Last step is I divide by 2, and I get x is equal to negative 3. So here we go. From our very simple equation, we had ended up with 2 different answers. Both answers are the solution, are correct. You need both. You can't just have one. Both of those satisfy this equation. Right? Because 2 times 7, 14 minus 4, absolute value of 10 is 10. Okay? 2 times negative 3 is negative 6 minus 4, negative 10. The absolute value of negative 10 is positive 10. So that's the key, making sure you set up both equations where the answers are positive and negative. We're going to do one more. Okay. So this time, we've got the absolute value of 2x plus 3 is equal to 5. So we isolate, okay? It's already by itself. There's no other numbers around here. We're not adding anything. We're not multiplying by anything. It's already isolated by itself, equal to 5. So we need to set up 2 separate equations, one where this equals positive 5 and one where this equals negative 5. So let's do the positive one first. 2x plus 3 equals 5. And then I'll put my little line in the middle. 2x plus 3 is equal to negative 5. Boom. Done. Let's solve the positive side first. We're going to add 3, or we're going to take away 3 from both sides. That could give us 2x equals 2. Well, what's that going to be? Well, x is just equal to 1. Let's double check. 2 times 1 is 2, plus 3 is 5. Absolute value of 5 is 5. We've checked it. It looks good. Now let's do the other side. Same thing, we're going to take away 3 from both sides. That's going to give us 2x is equal to negative 8. Remember, when you subtract a number from a negative number, you get a bigger negative number. Last thing we do is we divide by 2, and we get x is equal to negative 4. So there we go. There are both of our solutions. Double check that this one actually works. Okay? So if I have 2 times negative 4 plus 3, take the absolute value of that, that should be equal to 5. 2 times negative 4 is negative 8, plus 3, that's equal to negative 5. The absolute value of negative 5 is equal to 5. And voila, there we go. We can just do a quick check on our work there, just to make sure we're all on the right track. When we have absolute values in our problems, we have 2 solutions. There's always going to be 2. Okay. That is the basic understanding of our absolute values in equations. We're going to come back to it later. But for now, stay smart, stay safe. I'll see you next time. Bye!